Okay, in this video we will be learning how to multiply rational expressions. Now, when we multiply rational expressions, we go through the same or a very similar process as what we did when we simplified rational expressions. So the first thing that we want to do is to factor each expression in both the numerator and denominators. Then we will rewrite the problem into one fraction by using our multiplication rule for fractions. Then we'll simplify or cancel the common factors between the numerators and the denominators. Okay, so here we have 18 over x to the third times 5x to the second over 6. Now, you could break this down using your prime factorization, or you can simplify like it is, or you can multiply. And what do I mean by multiply? Multiplying 18 times 5, which is 90, times x squared in the numerator. In our denominator, we would have 6 times x to the third. Now, from here, we're just simplifying like we did in the simplifying rational expressions. So we know that 6 will go into 90 15 times. And when we simplify the like basis, we use the quotient rule. We have 3x to the third in our denominator, x squared in our numerator, so we have one more x in our denominator than we did in our numerator. So the answer to that would be 15 over x. Now, you can do it that way, or you can use your prime factorization and then cancel out the common factors that way. Expand the problem completely out. So 18. The prime factorization of 18, 2 times 3 times 3. That will make the 18 times the 5. 5 is a prime number from the second fraction. Times x times x. In our denominator, the prime factorization for 6 is 2 times 3 times x times x times x. Now, we want to cancel out the common factors. So 2 will cancel with 2. 3 will cancel with a 3. Have the 3 times 5 left there. And x will cancel with an x. An x in the numerator cancel with the x in our denominator. And you see we have one x left over in our denominator. So multiply that out. We have 15 over x. Same answer. Two different methods, same answer. Okay. On this problem, we have x squared minus 25 over x squared minus 3x minus 10 times x plus 2 over x. So again, same process. We want to completely factor each expression, write what we have all into one fraction, and then simplify. So x squared minus 25, the difference of two perfect squares. Simplifies to be x plus 5 times x minus 5. And then we have the x plus 2 in the second fraction. In our denominator, we have x squared minus 3x minus 10, factors of negative 10. That gives the sum of negative 3, x minus 5, x plus 2. And let's not forget this single monomial x. We'll put it right there in front. Now, after we get it completely factored, we go ahead and we simplify by canceling out the common factors. Now, remember, you have to cancel a binomial with a binomial or a monomial with a monomial. So, x minus 5 would cancel with x minus 5, and x plus 2 would cancel with x plus 2. So now our final answer we have left x plus 5 all over x. And remember, you cannot simplify that because in our numerator we have a binomial, in our denominator that's a monomial. You have to cancel binomials with binomials or monomials with monomials. Okay, this problem we're still doing the same thing. We need to factor after we get every expression completely factored. And we can write it all into one fraction and then simplify. So let's go out to the side here and let's factor 5x squared minus 180. So the first thing we have is a GCF of 5. X squared minus 36. However, it's not completely factored because we have this difference of squares here. So now we have 5 times x plus 6 times x minus 6 using our difference of squares rule. Okay, what about the 10x squared minus 10? So again, we have a common factor of 10. That gives us 10 times x squared minus 1. And I hope you see this again. We have the difference of two perfect squares, so we can factor that down to x plus 1 times x minus 1. All right, so let's see what we have so far. 5x squared minus 180, we have the 5. We have the x plus 6, and we have the x minus 6. In our denominator, we factor that. We had 10. Ended up with 10 times x plus 1 times x minus 1. All right. Now let's go to the other side and let's factor the 20x plus 20 and the 2x minus 12. All right, so 20 times x plus 20. All right, so we have a GCF of 20. So we end up with 20 times x plus 1. Now we already had a 5 out here in the numerator. So we'll just write that 20 out beside it to multiply it. And write the x plus 1 right there. What about the 2x minus 12? Well, I have a GCF of 2, x minus 6. So I have the 2 here, and I'll write the x minus 6 right there. So I completely factored everything and just wrote it all into one fraction. Now from here, if you like, you can go ahead and start simplifying, or you can multiply those monomials out and then simplify. So we could go ahead and multiply 20 times 5, which is 100, and 2 times 10, which is 20, or we could have simplified them like they are by simplifying the 2, the 10, and the 20. Okay, now let's see what we can simplify. 20 into 100. Well, you can do a quick way. You know 20 goes into 100 5 times, so that would leave us with a 5 in the numerator. What else can we simplify? Look for common factors between the numerator and your denominator. Yes, we have an x minus 6, and we have an x plus 1. So now that leaves me with 5, because 20 went into 100 5 times, times x plus 6, all over x minus 1 was left in my denominator. Okay, I hope you found this video to be helpful. Thank you.